Hi, this is Mrs. Kidman, and in this video, we are going to be discussing how we can deal with rational expressions. So we're going to be simplifying them in this video. In future videos, we're going to talk about how we can multiply them, divide them, add them, subtract them, all the beautiful things you can do with a rational expression. So let's start by talking about what is a rational expression. Well, a rational expression, like a rational number, is an expression that's written in the form of a fraction. So a lot of the ones that we're going to see is going to end up being some type of polynomial on top and some type of polynomial on the bottom. That's what makes it a rational expression. However, we really can, in a rational expression, have any type of expression on the top and on the bottom, but what makes it rational is that it's in that form of a fraction. Now, what we're going to be doing to start in this video is we're going to be simplifying rational expressions. So what that means, when it comes to simplest form, that means there's nothing in common. And I'm going to put common in quotes here because it's not that we can't have a 2 on top and a 2 on bottom, but we can't have any common factors. So nothing in common, meaning there's no common factors between the top and the bottom. So what we're going to do here is we are going to practice simplifying different rational expressions. And the way we have to do that, because we want no common factors, is we are going to factor completely, as much as we can, anything in these rational expressions. And then we're going to cancel out or get rid of anything that's in common, because remember, anything divided by itself, which is really what a rational expression is taking something and dividing it, is always going to be 1. So we can simplify that down to 1 and get rid of it. So let's take a look at a couple of examples here where we are going to simplify these rational expressions. So let's start by simplifying this expression here. We've got 8x to the third power times y divided by 2x y squared. So if we were to factor this out completely, what we're talking about is we're saying I've got a 2 times a 2 times a 2, that's the prime factorization of that, times x times x times x times y divided by 2 times x times y times y. Okay, so it's all factored out completely. Now, for the sake of this video, I'm going to list them out. However, at some point, you're going to get to the place where you don't have to list them out every time. So for the first few examples, I will list them out. After that, we'll just kind of talk about what's in common and get rid of it. So here, I've got a 2 on the top and bottom, so we can simplify that down to 1. I've got an x in the top and bottom we can simplify down, and I've got one y that I can simplify down. So then what happens is when I simplify it, after I get rid of all of those common factors, I write out what we have left over. So in this case, we have 2 times 2, which is 4. I've got x squared, no y's on top, and I've got a y on the bottom. So this is the simplified form of that. Awesome. Okay, let's take a look at a couple more examples here where we do a similar thing. So in this case, we want to factor it out just like we did before. So 7 times x times x times x times x times y times y times y divided by 7 times 2 times y times y. Then we get rid of what's in common with both. So these simplify down to 1, and 2 of our y's simplify down to 1. And so we end up getting x to the 4th y over 2. That's how that one will simplify. Now, what happens when we have something like this next one here? Well, in this next one, rather than listing out every single prime factor, which works, what we can do is we can use the properties that we know about exponents to actually simplify it. So this 128 and this 16, the very first thing I want to do is see, can I just cancel out that 16 altogether? And how do I decide if I can cancel that out? Well, I just need 128 to be a multiple of 16. So if I do 128 divided by 16, I get 8, which means that this is really the same as 16 times 8, and I can cancel out those 16s. Awesome. So we're left with an 8 on the top. Now let's take a look at our x's. I've got 4 x's up here and 3 down here. So the lower number is going to get rid of, and I'm going to subtract 3 from here. So if I do 4 minus 3, we get 1. So I've got an 8 on top, I've got 1 x on top, I've got 1 y here and 2 here, so this one will get rid of, and 2 minus 1 is 1 y. And then we've got 3 z's on top and 4 on the bottom, so the lower number we'll get rid of, we'll subtract it, and we end up with a z on the bottom. So notice how this one simplified down into 8x over yz. So we can always, it's never wrong to list them all out, but we can also simplify using some of those properties of exponents as well, and knowing about common factors to simplify those expressions as well. Now this works great if we have a monomial or a one-term expression that we're trying to simplify. But what happens when I end up with an expression like this one, where it's not a monomial? Now, a lot of people have the tendency when they try to simplify to say, I can just get rid of this and this. But we can only get rid of things in common if they are being multiplied. Are these being multiplied? Is it x squared times something? No, when they're being added or subtracted, we cannot just get rid of them. We can only get rid of things that are being multiplied together. So how we turn it from an add subtract problem into a multiply problem is we factor. So to simplify expressions, the very first thing we want to do is factor it. And that's what we were doing before, right? Up here, we were factoring it out completely. That's what we want to do every time, factor completely. So let's take a look at it. Let's factor these completely. So I'm going to create my x method here. I want two numbers that multiply to -12 and add to -4. Well, I can think of a -6 and a 2. So on top, this is the same as x minus 6 times x plus 2. And on the bottom here, that's one of our difference of squares. So it's an x times an x and a 2 times a 2. So this is going to end up factoring into x plus 2, x minus 2. Okay, factored completely. Our second step when it comes to simplifying expressions is we want to cancel out what's in common. We want to cancel out what's in common. So in this case, we're going to cancel out these two x plus 2's because there's one on the top and there's one on the bottom. And then we end up getting x minus 6 divided by x minus 2. Is there anything else that we can simplify here? No, because they're factored completely and there is nothing to cancel out. Remember, we can only cancel things out if the operation between them is multiply. In this case, on the top, we have a subtraction problem. And in the bottom, we also have a subtraction problem. So neither of those can cancel anything out. So this right here, this x minus 6 over x minus 2 is actually our simplest form of that expression. Let's take a look at a couple of more examples here where we simplify these expressions. So this first one, remember, we always want to factor completely. This first one is already factored for us. So then our second step is to cancel. So let's take a look here. What can I cancel out? My x plus 1 and my x plus 1. So this ends up getting me 2 over x plus 3. Now the top is just a monomial, as simple as it can get. The bottom is an x plus a 3. Because the operation between that x and 3 is not a multiply, I cannot cancel anything else out, and this is my simplest form. Now let's take a look at this next one over here. We now have a trinomial on top of a trinomial. So just like we did before, our first step when it comes to simplifying an expression is to factor it. So let's go ahead and factor these. I want two numbers that multiply to -3 and add to -2. Well, that'll be -3 and 1. So on top, I've got an x minus 3 and an x minus 1. Now on the bottom here, I've got two numbers that multiply to -6 and add to -1. That's what we're looking for now. And these are going to end up being -3 and 2. So we end up getting an x minus 3 and an x plus 2. So then with that, our second step is to cancel what's in common, and that's our x minus 3's. So we end up getting an x minus 1 over an x plus 2. Now, are these two expressions as simplified as they get? Yes, because between that x and that 1 is a subtraction sign. Between that x and that 2 is an addition sign. Because they're not being multiplied, that is as simple as we get. So if you have questions about how to simplify these rational expressions, please reach out. But remember, the steps that we're going to follow to simplify any rational expressions is 1, factor it completely. Break it down as much as possible, both the top and the bottom of our rational expression. After they're both factored out as much as they possibly can be, then we cancel out what's in common. Once everything's been canceled out, there is nothing else that we can still cancel out because we factored it as much as we possibly can. So that is our simplest form. If you have questions, please reach out, and I'm happy to help. Please check out the next video in which we discuss how we can multiply rational functions.